So now let's look at some different problem types from a different exercise where the problems are a little bit more abstract than just plugging them into the calculator. So let me just rewrite this first. Let me make some room first. We have log base 2 of c multiplied by log base c of 2. And let's rewrite each of these using our change of base rule. And we can use either natural logs or common logs, but it looks like our answers use the common log, so let's do that. We'll rewrite each of these using a common log. So for this first one, we're going to rewrite it as log base 10 of c divided by log base 10 of 2. The original input goes in the top logarithm and the original base goes in the bottom logarithm. Now for the second one, we'll do the same thing. We're going to use the common log, and 2 will go in the top, and we have the common log of c in the bottom. Now what you might notice is that we have log c up top, log c down below, so those will cancel, or essentially they'll divide, and the quotient will be 1, since something divided by itself is 1. And the same thing will happen to log 2, since you have it in the top and the bottom, so those will also cancel. And this will essentially just be equal to 1. So our answer here would be choice letter C. So let's look at some different ones, but the strategy for these will be pretty much the same. We're just going to rewrite each of the logarithms using the change of base rule to see if we can make some simplifications. So we have log base 4 of m multiplied by log base m of 20. Now let's rewrite each of them using that change of base rule. And for this first one, we'll use the common log again, since that's what they use in one of the answer choices at least. So we have log of m, log base 10 of m, divided by the common log of 4. And for this other one, we have the common log of 20. So the top number goes in the top logarithm, and the base goes in the bottom logarithm. Now for this one, notice we have log or common log of m in the top and the bottom, so those are going to cancel. And so we just have log of 20 divided by log of 4. Now this is not one of the answer choices. You might be tempted to say it's D, and in fact that is the correct answer, but let's understand it. At this point, we're essentially going to use the change of base rule in reverse. So remember, the change of base rule, if we write it out generally, log base a of b is equal to log base c of b divided by log base c of a. So we're basically on this right-hand side where, let me just rewrite it with base 10. So log base 10 of 20 divided by log base 10 of 4. Notice that our c value from this formula is 10, and our b value is 20, and our a value is 4. So we can go back to this original logarithm, recombine them. So if you ever have a quotient of logarithms, you can combine them back into one logarithm, where the base is the input of the bottom logarithm, so we'll put a 4 there, and the input of this logarithm is the input of the top logarithm, so 20 right there. So our final answer is log base 4 of 20. And of course, you can double check this by just doing it in reverse. Use the change of base rule and prove to yourself that it would go back to this quotient here. So let's move on. We'll do another problem, and we'll apply the same method. So this one we have a quotient, log base 5 of m divided by log base 15 of m. And let's use the change of base rule for each of these. So this is equal to, in the top, let's use common log. We have log of m divided by log of 5. And in the bottom, we have log of m up top and log 15 for the denominator. Now we have two fractions within a fraction, so this is a complex fraction. But just keep in mind the general idea with fractions. Like if you had 1/2 divided by 2/3, dividing by a fraction, remember it's just the same as multiplying by the reciprocal of that second fraction. So we can apply that here. So this will just be a side note and essentially change this to multiplication. So let me change colors here. We have log base 10 of m divided by log base 10 of 5. That's our numerator. We don't change that. And now we change it to multiplication rather than division, and we flip the bottom one. So we have log 15 up top and log m down below in the denominator. Now you can notice that log m will cancel out since it's in the numerator and denominator, so that quotient will just be 1. And we can rewrite this as log of 15 divided by log of 5. And since we have a quotient and they have the same base, in both cases the base is 10 here, so we can use the change of base rule in reverse, where the new base of this logarithm would be 5 since that's in the denominator, and the input would be 15 since that's in our numerator. And of course, at this point, just convince yourself this is true by taking this and applying the change of base rule to go backwards. But our answer, log base 5 of 15, would be choice letter D here. And let's just do one more problem. So we have another quotient here, very similar to our last one. We have log base b of 8 divided by log base b of 2. We're going to apply our change of base rule to the top and the bottom. And we'll use common log again. So we have common log of 8 divided by the common log of b. And we'll divide this by the common log of 2 divided by the common log of b. And since we're dividing by a fraction, we'll change this to multiplying by this bottom fraction flipped over, by multiplying by the reciprocal, essentially. So we have log 8 divided by log b. The numerator doesn't change. And then now we're multiplying by this fraction flipped. So it'd be log b divided by log 2. And log b divided by log b, that is going to be 1, so those cancel. And we just get log 8 over log 2. And we have a quotient where the base for each of these is the same. So we can use the change of base rule in reverse and rewrite this as log base 2 of 8. And this is actually solvable. You might remember this from the intro video, where 2 raised to the third power gives us 8. Or if you don't remember, you essentially set it equal to some variable, rewrite it in its exponential form, so it'd be 2 to that missing exponent. Logarithms are always equal to the missing exponent. And the 8 is what this exponential expression is equal to. And you can see 2 to the third power gives you 8. So in this case, x is 3, or our logarithm is equal to 3. And you can see that is choice letter A here.